Hello and welcome to video lesson topic 10.7, where we are talking about areas of circles and sectors. Today's learning objective is I am learning to find the areas of circles, sectors, and segments of circles. Basically what that's going to equate to is you could find the area of an entire circle. Like here you got the whole circle with some radius. The area is pi r squared. You could find the area of a sector of a circle, which I would equate to a slice of pi. Like if the circle is a pi, the sector would be like maybe this shaded in region, a slice of the pie, which does have a formula. It's whatever this arc is, like let's say from A to B here. And this is radius, and we'll call this circle O. The measure of this arc, however many degrees, divided by 360, just like in the previous lesson, 10.6, times this time instead of circumference, we're going to multiply by the area of the circle. So pi r squared. And then the segment of a circle, if we got a whole pie or pizza or whatever you want to say, and then a slice, a segment would just be the crust. So the crust would be like, say you got circle Q here. The segment would be as if we drew a line segment that connected the two endpoints of this arc. We'll call it arc XY. This shaded in region would be the crust, as I like to call it, or segment of a circle. If you want to get technical, the book reads as a part of a circle bounded by an arc and the segment joining its endpoints. Now, for example 1, it says, how much more pizza is a 12-inch diameter, that's D equals 12, versus 10-inch pizza? Now, something to keep in mind here, we need the radius if we're going to work with area. This basically says, in this picture, we got a big pizza and a slightly smaller pizza. One has a diameter of 12 or radius of 6. I got that by cutting 12 in half. One has a diameter of 10 or a radius of 5 if we cut that in half. Now, with that in mind, we want to know how much more pizza is in this larger one. So we need to find the area, which is pi times 6 squared, and find the difference between that area and the smaller pizza. So you'd have to subtract those two. Now, according to my calculator, pi times 6 squared is 113.1, and pi times 5 squared is 78.5. So if I subtract those two, now I'm rounding here, so it may be off by just a little bit, but I got 34.6 inches squared. That's how much more area I would have in the larger pizza versus the smaller. Now, example 2, we're going to take a look at, what if I didn't want the whole pizza or pie or whatever? What if I just wanted a slice of it? Now, it may be hard to see on yours, or on this video rather, but if you're looking at the PDF from Google Classroom, you're going to see that you have ZOM here with a 72-degree central angle and a radius of 20 centimeters. And it says leave your answers in terms of pi, which we discussed. Don't put pi in calculator. Pi needs to go in your answer. Find the area of this sector. Now we're going to need the formula from up here. However many degrees your central angle is divided by 360 times pi r squared. So however many degrees our central angle is over 360 times pi r squared, in this case 20 squared. If I'm going to do this in my calculator or on an iPhone, let's say I'm doing it on the calculator. I'm going to do parentheses 72 divided by 360 times 20 squared. 80. Notice I did not put pi in the calculator. It goes in my answer. 80 pi centimeters squared would be the area of just the sector. Now, example 3, find the area of the shaded segment. Round your answers to the nearest tenth. Now, this says that we have 10 as our radius here, and this is a 90-degree angle, and this is 10 as well. So this one's going to be a little bit easier than 4. I'll go ahead and give you fair warning. So find the area of just this shaded segment. Well, if we find the area of the whole slice, like we did in example 2, we can just subtract off the area of triangle AOB. And since this is a right triangle, that's why it's going to be so easy for us. The area of just this slice of pie, the whole pie, is 90 over 360, and I'm getting that from the measure of the central angle, times pi 10 squared. Remember, that is the entire sector. We want just the segment. So now we have to subtract off the area of the triangle. Now, lucky for us, unlike example 4, this has the base and height already given because this base is horizontal, this height is horizontal. If you look at example 4, this base is horizontal, the height is vertical. Example 4, we don't have the vertical height. This is going at an angle. So that's going to be an issue for us. On here, it's going to be as simple as 1/2 times base times height. That's the formula for the area of a triangle. Now this is round to the nearest tenth, so you can stick it into your calculator all at once. And if you do, you will get 28.5 inches squared. Our last example, the reason why it is so much more difficult is, again, we don't have that vertical height. So whenever we're subtracting off the area of this triangle, because we want to know the area of this shaded region here, we can't do 1/2 6 times 6. We can go ahead and find the area of the whole slice. It's got a 120 degree central angle. So we'll do 120 over 360 times pi 6 squared. But we'll have to subtract off the area of the triangle. Now, I taught you guys in the previous section this 1/2 BC sine of A formula. And that is, if you know this angle and you know the measure on each side, you can substitute them into this formula. Well, since we have the radius here, all the radii are equal. So B is going to be 6, C is going to be 6. Angle A is the 120 degrees here. So we're going to subtract off 1/2 6 times 6 sine of 120. This can be complicated to put into like an iPhone. So if you have a calculator or if you have access to the internet where, I assume you do since you're watching this video, but if you have access to like web pages where you could just type all this in, make sure it's in degree mode, because if not, it's going to give you the wrong answer. You can see mine says degree mode at the top. So if we plug all this in, and it says round to the nearest tenth, so we don't have to leave pi out this time, I'm going to substitute it in exactly like I have it written down. And when I do that, again, make sure you're in degree mode. My calculator says it is 22.1. And that would be centimeters squared.